Hello students of class 8 once again. I am Sudhir and welcome back to my video. In today's video, I will show you some of the remaining questions of this exercise 11.2, okay, and also the other portion of this chapter. So today I will start with the question number 8 here. So question number 8 is saying that Mohan. Please check, you can check your question from the book. I'm not writing the question here, but in the question is saying that Mohan, a person is there called Mohan. So he bought one plot of land, okay, one plot of land which is in trapezium shape, okay. So one side of the trapezium shape of his plot is on the road side and another side is along the river lines. This is the logical. So he said that the distance, the perpendicular distance of the road side and this river side of the plot is 100 meters. Perpendicular distance. Okay, so this will be the height of this trapezium. So in this exercise 11.2 is mostly deal with this shape of trapezium, and then we have to apply the area to find the area by applying the formula of trapezium, this area of trapezium. Okay, nothing is to be confused. There is no much big thing here. Only just to remember the area of the trapezium. What is the area of the trapezium? Then you apply the unit. See, we have to find out the length of the site or length of the border. We can say border of the plot, isn't it? Border of the plot. The border of the plot is along the river side. This border of the plot along the river side is the side of this trapezium, isn't it? The longer side of the trapezium. And this side along the road and the river are parallel sides. This border are parallel. This border of the land are parallel. This along the road side and another one is along the river are parallel to one another, and their perpendicular distance is given as 100 meters. And in the question, the area is given. The area of the plot is given. So what we have to find out is that we have to find out how much length of the side along the, how much the length of the border, how long the border of the side. I mean, how much length of the border that along the river side that we are going to find out. So what we are going to find is very simple, because the question is given that in the question a condition is given there. The condition means that how much is the length of the site, or how much the length of the border along the roadside, okay, is, let's say, half of it. Means the border along the river is twice the length of the border along the side. Once again, the length of the border or the length of the side along the river is twice the length of the border or length of the side along the river. So with this condition, now let us start our solution. So area of the plot, it is 10,500 meters square. Border along the river side is to be found. Now, according to the question, so let the border along the road side be x. We don't know. Let it be x. Then the other side along the river, the other border or the other side along the river. So say side here. The other side along the river's side, along the river or river side. Okay. Along the river side will be twice x, because 2 times of the road side. The side along the road, okay. The side along the river is 2 times the side along the water. So 2 times is twice. If this x, it will be twice x. Isn't it? Once again, let the boundary along the road side be x. Then this is then. Then other side along the river side, or other border along the river side will be twice x. Then you understand, isn't it? Then by the question, we have that area of trapezium trapezium of A, or you can say area of the plot, equal to half into height into A plus B. We got it, isn't it? Yes. So what happened? We can just imply that, okay, area of trapezium is given there as 10,500 meters square, and there's half into height, how much? 100. Okay, how much? 100 meter into A. Let A be the x, or you can say any of it, and B be the twice x. Because A plus B is the sum of A plus B is the sum of the two sides which are parallel. Isn't it? Sum of the two parallel sides, or sum of the parallel sides. A plus B is the sum of parallel sides. So x plus twice x, isn't it? Yes. So this is not A, this should be x plus twice x. Okay. From here we will find out the x value, then we will get the length of the side, or length of the border around this. Okay. So I want to write all this part here, and this will be okay, that is 1 by 2 into 100 into x plus 3x will be 3x. Yes. Then equal to 10500. These two we can cancel it. Yes. If you cancel these two, you are getting here 50. Isn't it? Yes. 50. Then you are getting here 3x is equal to 10500 divided by 50. Right. Then now you see here, you can cancel this 2, isn't it? Then how much will be here? 2. Then 1, 0. Okay. Yes. I'm taking here. So to here, one more 0 will be here, then 1, 0. So you get here like this, and you cancel this. Okay. Yes. So 2010 you are getting here. Next implies that 3x is equal to 2010. Now x is equal to 2010 divided by 3. How much will it be? Just take it. Okay. So once again, my test will come here in this division. So we don't need to get one more 0 here. Okay. So 5 to the 10 and 5 to the 50. Yes. You get here 210. So 3x equal to 210, and this 210 will be divided by 300. Isn't it? And x is equal to 70 by 2. Now we get x is equal to 70. Means 70x equal to 70 meters. That means the side along the side along the rod is 70 meters. So the side along the river will be 2 times of it, isn't it? So now you get the value of x. So therefore the side along the river is equal to twice x. That means 2 into 70. That is 140 meter. 140 meter is the answer of the question. Means the boundary along the river side, or the side along the river. Okay. So this is the answer for question number 8. Now let us go to next question. So hello friends, next question we have question number 9, and question number 9 actually it is the statement is given like a kind of space is there. Okay, a kind of space. I mean, a top surface of a raised platform is in the shape of a rectangular octagon as shown in the figure. Find the area of the octagonal shape. Suppose this like that a roof. Okay, understand? So top of the raised platform. Top of the raised platform, you know platform, yeah, just little above the ground, isn't it? So it was in the octagonal shape. Octagon means having 8 sides. Okay, and it is a regular octagon. Regular octagon means all the sides of the octagon will be same. So a side is given there as 5 meters. So I am also written here length of the side of a regular octagon is 5 meters. Now we have to find out the area. We have to find out the area of the octagon. So area of octagon, how we find out? See, the same is given in this book. So what happened? Now this is a polygon. So polygon we are trying to make them into different figures. See octagon, you can see according to the figure, according to the diagram given here, you see used to get one trapezium, isn't it? So there will be another trapezium again. Then one rectangle. So two trapezium, two equal trapezium and one rectangle you will find here in the whole octagon, isn't it? So if you find out the area of one trapezium, then another trapezium, area of two trapezium will get, and the area of one rectangle together will be the area of the whole octagon, isn't it? Yes. Now you see here. So I used to give here like this. Yeah. So area of the octagon equal to area of two equal, isn't it? Two equal. Why equal? Because all the sides are same, isn't it? And you can see that the gap between, okay, the gap between from this point to this point is given as 11 meter. 11 meter. Okay, this from here to here is 11 meter is given from the question itself. Okay. Now you can see area of the two equal trapezium plus area of the rectangle. The area of rectangle. So if you add this area, then you will get the area of the whole octagon. So very simple, isn't it? So that means write down area of the two equal. So 2 into half, okay, into height, then yes, a plus b, yes, a plus b, then plus this is about the area of trapezium and plus area of rectangle. Rectangle L into B. Isn't it? Area of the this one is L into B. Just try to put the value 2 into 1 by 2. Okay. 1 by 2. Let us put this in the bracket. After all, okay. Also. Then into, and how much will be that? 4 meter. Into a plus b. A how much? A will be 5. B how much? B 11. Isn't it? Yes. B 11. Plus L how much? L 11 into B how much? 5. Now let us go along with this. So 2 into, okay, in the bracket you see these two can be cancelled, yes or no? Yeah. So you will get here 2 into how much? That is 55 plus here 55. Now you got here 2 into 55 to 55 means 110, isn't it? Yes, 110 plus 55. Yes. Now here not 55, okay, it is not 55, here it is 16, and here you get here 15. This is not multiplication, it is plus So 5 plus 11 is 16. Okay. Then we will continue with this. Okay, so here 2 into 16 means yeah, 32. So 232 how much? 232 you are getting here 64. So 64 plus 50 means 119. 64, yeah, 64 you get 64 here, isn't it? 64 plus 55 means yeah, 119. Yes, correct, 119. So 119 meters square is the answer for the question. Means the area of the octagon. The area of the octagonal shape of the platform. Okay, the top surface of the platform will be 119 meters square. Okay, so this is the answer for question number 9, and let's go to next question. Hello student, question number 10 is very simple. A diagram is given here. So you have to measure the area in two different ways of the same diagram. So it was in the question it says that some two students are there, or two girls are there, two persons are there. They used to visualize, they used to see the same shape in two different ways, and they calculating the area. So that you have to do. Now for this question number 10, sorry 11, I'll show you. See, a frame is given here. Frame. Okay, this is the frame here, and the question is saying that the wide of the frame. This is the frame. Okay, so the wide of the frame are all same. Are all same. So the side of the inner part. You see the side inner part. This is 16. The dimension. Okay, 16 by 20 here, and the dimension of the outer part is 24 by 28. So what we are going to do is that we are going to find the area of the frame of each section. Section 1, 2, 3, 4. This section we are getting, so it's how much they are getting. But you see, each are of trapezoid, isn't it? So how much is? My dear friend, S is a regular frame. So this section and this section will be same. This section and this section will be same. So we need to find out the section here and section here. These two sections. So the other section will be equal as this. This section will be equal to this. This section will be equal to this one, isn't it? As this side is equal to this side will be equal to this side. So this section will be equal. This section will also be equal. So we need to find these two sections out. So in these two sections you see here, by then we need the distance here. Distance of the line here and distance of the line outside here, isn't it? So what is this distance? This distance is the white. Here all will be equal. So here also will be another same thing. Yes or no? Yes. So what happened? Just see inside to find out the white here. If you minus 20 from 28 and divide by 2, you have to minus this part from here and divide by 2, you will get how much the gaps are. Because the gaps here will equal to this gap. That means perpendicular distance. Okay, perpendicular distance of this line and this line will equal to the perpendicular distance from this line and this line here. So there are two equal gaps which is less than 20 e. But from here to here it is given as 20 centimeters. So what happened? You subtract 20 from 28 and divide by 2. You will get it the white of 4. How much is there? You know, okay. But there are together 4 white. Only 2 white will take because this one, the white here and the white here. So that you divide the difference of these two lines, 20 centimeter and 20 centimeter. Okay. So white, how will you get the white? 28 centimeter minus 20 by 2. 2 white because same white, isn't it? So this part, okay. we will supply from this side. Okay. Then how much we are getting here? We are getting here 8 by 2. That is 4 centimeter. So 4 centimeter is the width of all the flat. Now if you get the width, what is the width? The perpendicular distance of these lines, isn't it? Then this perpendicular distance will become the height of trapezium of all this. Isn't it? Means the width is the height of all the trapezium. So you have to find the area of trapezium here and area of trapezium here. Isn't it? Then you think the area of all the sections. For these sections, you go to this section. For this area of the section, you go to the area of the section. You get these two areas. So we are going to find out the area of these two. Let's say trapezium. Okay. So now we know that area of trapezium is equal to half into height into A plus B. First one, in the first case is, that means half into, what is the height? Height is the 4, isn't it? Into AB. Here AB will be 16 plus 24, isn't it? And how much we get here? 2. 2 into how much? 0. 10. 4. 40. That means 80 centimeter square. Why we get 80 centimeter square? Okay. First one we get 80 centimeter square. Second section means here section. Area of the trapezium means area of a section. Area of a section. A section is written here with the dimension of 16 and 24 centimeter. With the dimension of 20 centimeter, let us see what is the area of the trapezium. Again, area of a trapezium is equal to half into 8 into A plus B. That means half into 4 into A plus B. A 20, B 28, right? Or you can write A 28 plus B 20. Doesn't matter. Okay, clear? So let A we take the longer side. Okay, doesn't matter. Anyway, then here, that means 2 into how much? 2 into 48. 48. So how much we have 48 you see here? Yes, it is 96 meter square. 96 meter square is the area of the another section. One section is getting as area 80 centimeter square, another section has 96 centimeter square. Okay, so we got the area of all the sections. So this is answer for question number 11, and now this is the end part of the exercise 11.2, and now let us go to the another section of the chapter. So there is surface area of solid or the solid set. Okay, so the chapter is dealing about the solid set. So there we are going to deal about the surface of the solid set. Solid set means the 3D sets. Okay, cuboid or cylinder, they are all solid set. So we are going to discuss about their surface area. Okay, we have finished about the area of the trapezium, area of the parallelogram, and area of the rhombus and so on. We have finished. So now we are going to the area of the surface of some solid substances. Okay, or solid set. So let us go to the next part. Hello students, this surface area of solid set is very important. Okay, please put a little focus here. Now, first of all, let's consider about a shape called cuboid. Now, you know what is cuboid? Cuboid is the 3D shape of rectangle. Okay, the 3-dimensional shape of rectangle is called cuboid. So you see, for a cuboid, how many faces are there? There are altogether 6 faces are there, isn't it? So area of these 6 faces, all the faces will be in the shape of rectangles. Isn't it? In the shape of rectangles, and there are together 6 faces are there. 6 surfaces are there, or 6 faces are there, and these 6 faces, if you want to find out the area of these 6 faces, this 6 faces is known as total surface area. Surface area. Okay. If 6 faces are there, then it is total surface area, and the formula to find out the total surface area of the cuboid. Total surface area of cuboid. Cuboid is 2 into LB, length into breadth. Length, breadth. Okay, length into breadth. Understand? And what about this edges here, line plus L length into height plus breadth into height. Breadth into height. Breadth into height. Okay. So once again, total surface area of cuboid is 2 into LB plus LH plus BH. Okay, that means 2 into L length to breadth plus length to height plus breadth to height. Since it is a 3-dimensional shape, there will be height. Isn't it? That's why. There is height, that's why it is 2 into LB plus LH plus BH. Don't forget, okay. 2 into LB plus LH plus BH is the total surface area. And one more thing is that, see, this surface is top and down is floor. Okay, bottom and top. If you remove the bottom and top, sometimes in your room, okay, your room is also one of the solid shape. Okay, it is also 3-dimensional shape where there is length, breadth, height are there, isn't it? So what happens? Sometimes you need to consider only the face of the wall. On the wall is the surface of your surface of the solid shape of your room, isn't it? So what happens? Roof part and the floor part sometimes not considered. For example, in painting the wall, okay, you paint the wall only, but top is roof and the floor are not considered. So this four surface of your room, 4 surface of the wall, 4 surface of the 4 wall of the room is known as the lateral surface. Lateral surface, okay. So what happens? Like that, here also you will get 4 surfaces are there, excluding the top and the bottom. It is called lateral surface, isn't it? By removing the top surface and the bottom surface, the other surface is called lateral surface. Lateral surface, okay, which stand upright is called lateral surface. These are surfaces standing upright from here. Wall also standing upright, isn't it? So the surface standing upright is called lateral surface without the top. This is flat one. Flat. Top and the bottom are the flat surface, isn't it? So excluding the flat, top and bottom are called flat surface. The upright standing upright surfaces are called lateral surface. For example, let us say you have a cane like this, isn't it? So this part is called the lateral surface. This surface is called lateral surface. This part is called top surface, bottom surface, isn't it? So excluding bottom and the bottom and the top, the other surface is called lateral surface. Lateral surface. Lateral surface. Okay, lateral surface. Understand? So now when you find out the surface area, you will get 2 types of surface area. One is called total surface area. Total means with top and the bottom, and lateral means without the top and the bottom. It's called lateral. For example, the four wall of your room is called lateral surface. Okay. Now, lateral surface area of cuboid. If you want to find out only the area of the four surface, upright surface, which are standing upright, not flat. Okay, like the surface of the four walls. They are called lateral surface. So if you want to find out area, then it is called lateral surface area, and lateral surface of the lateral surface area of the cuboid is Q equal. So this two will be there, okay. And what h will be there? It's twice h, twice height into L plus B is the formula to find out the lateral surface area of the cube. Once again, lateral surface area of the cube is twice h into L plus B, and total surface area of the cube is 2 into LB plus LH plus BH. L stands for length, B stands for breadth, again L stands for length, H stands for height, B again stands for breadth, and H again stands for height. So these are the formula that you have to remember to find the total surface area and the total surface area of the cube, okay, of any cell. Let's go to the next part of this chapter. Now, hello students, next we have the cube, okay. So let us find out the total surface area of the cube. Total surface area of a cube. My dear students, look here. There are also 6 faces are there, isn't it? 6 surfaces are there, or 6 faces are there in the cube. So what about the cube? All the, whether length or breadth or height, all are same. If you take this as L, this will also be L, this will be also L, this will be also L. So everywhere you find that the dimensions of the shape is L, or the dimension of the face, L, length and the breadth will be L, L, L. So how many faces are there? 6 faces are there of square, isn't it? So square, you see there, if you just add L into L, surface area L into L, L into side to side, L into L, plus L into L. So 4 times you are going to, so 6 times you are going to 8, isn't it? 1, 2, 3, 4, 5, 6. 6 area of the surface area, isn't it? So each you will get that as L square, side square, isn't it? Side square. The area of the square is side square. Side square is L square. We are taking as L, then L square, isn't it? Yes. So how many are there? 6. So you do multiply with the 6. So 6L square is the total surface area of cube. Then you don't forget. Okay, clear. Lateral surface is 4L square. Okay. So here 6L square is the total surface area of cube. Cube 1 is different from cube. Okay. Now with this, let's go to the next part of the circle. Next part of the circle is about cylinder. Okay. Cylinder. My dear friend, cylinder are of 2 types. Okay, one cylinder is like this. Where the center of this circular, if you join, then it is not vertical. This is also a cylinder. Okay, the center of this circular surface is joined, then you get here on the base not 90 degree, less than 90 degree or more than 90 degree. Clear? But you will get one cylinder like this. You will join the center part of the center point of the circular surface, then you get a 90 degree. This is called right cylinder. Okay, so we are going to discuss about right cylinder. This kind of cylinder we will be discussing in the later on classes. So we are going to discuss about this right cylinders and to find out the total surface area or lateral surface area. Okay, see, lateral means only this part. Total surface means along with the top and the bottom, the flat one, isn't it? The round part. I mean the circular part, the round part. All are circular, but the flat part, the flat surface, top and the bottom, along with this, the what is it? The upright surface. Okay. Together is called total surface. But lateral surface means only that the upright part, not the top or bottom. Without the top or bottom is called lateral, isn't it? So here also we find the total as well as lateral. Okay. So let us see what is the total surface. Total surface area of a cylinder equal to, okay, my just friend, if you cut the top part and just straight, you will get a rectangle like this. Yes or no? Rectangle, if you just make it bending, then it becomes the cylinder. Yes or no? This part will be rectangle, you cut and straight. Okay, clear? And top part will be like this. So area of this rectangle and area of these two circular parts together will be the total surface area of the cylinder, isn't it? So that my just when you do here 2 into area of circle, that is pi r square, isn't it? Pi r square plus L into B. L into B, you just take here L into B. So L into B will be the L issue height, because breadth will be the height of the cylinder, isn't it? But here, my dear student, here we have little illusion here, little more, what to say, kind of logic is there, okay, about rectangle. You cannot take as a rectangle directly, but what you can see, length, as rectangle is length, but this length you just bend to make the cylindrical shape, okay, cylindrical shape. This length will become as a circular part, isn't it? That means it become this part will become, this L will become as the circumference of the circle. What is circumference of the circle? 2 pi r. 2 pi r, isn't it? 2 pi r, okay. So this is the 2 times of the area of 2 circle here, isn't it? And now this L becomes 2 pi r, the circumference of the circle, isn't it? And this is the height. So what happens? It is 2 into means 2 pi r, 2 pi r square plus, okay, then 2 pi r h. Two pi r h, and L just we have to replace with this circumference, because you see when we bend, this length will be making circular and become the circumference of the circle. So instead of L, we are taking circumference of the circle 2 pi r, L 2 pi r into x means h. So from here you see 2 can take common, isn't it? 2 can take common, 1 pi also can take common, and 1 r also can take common. Then it is into in the bracket r plus h. So this is the formula to find the total surface area of the cylinder. 2 pi r into r plus h. Okay. Then lateral one. Let's see. Please note down this. Okay, total surface area of a cylinder is 2 pi r into pi plus r. So now with this you see, so what will be the lateral surface area? Lateral surface area of cylinder. What will be? Tell me, lateral surface area of the cylinder. Lateral surface area of the cylinder. What will be the lateral surface area of the cylinder? Now, you see here, lateral surface area is here. So what we have got in LH, isn't it? So it is equal to L into H. Not B. H. B. Actually, this is height. Okay, it's become height of B. Then into breadth. Then is L into H. L H. So L, how much is L? Is that L is twice pi r x. So twice pi r x is the lateral surface area. Please. Okay, twice pi r h is the lateral surface area of the cylinder. So with this formula, we have to solve. We are going to solve the questions from the exercise 11.3. So that solution or solving the problem will be doing in the next video. Okay. So for today here I come to the end of the session, and yeah, so we meet again in the next video. Till then, have a nice day all of you, and take care. Thank you once again for watching this video. Bye bye.